Modern foundation technology is demanding ever higher standards from piling equipment. Reliability, efficiency, environment-friendly operation, and multifunctionality needs are steadily increasing. And it is important that the contractor is continuously in the picture as to how equipment is performing. He must be able to control the minutest points of the piling process. IHC Hydro Hammer has developed a state-of-the-art piling hammer which is opening up a totally new era. It is based upon a revolutionary hydraulic hammer with some extraordinary characteristics that have earned it the reputation as the first intelligent piling unit. A low-weight hammer, but with controllable energy per blow and high performance for cost-effective operation both above and below water. The hydro hammer is equipped with a sophisticated control panel. Energy per blow is measured at each stroke and displayed on the control unit. Should a fault develop, this is immediately shown on the panel. This is especially important during underwater work when the process can be neither seen nor heard. IHC's years of experience in design, production and use of hydraulic piling hammers is clearly demonstrated in the hydro hammer, a unique system that is different from others in more respects than one. In the hydro hammer's closed housing, the ram is integrated with the piston rod. Oil flows from the power pack through the delivery valve to cylinder chamber and returns through the return valve. At rest, both valves remain open and oil circulates. The valves and accumulators are shown next to the hammer. In fact, they are within the hammer. The chamber above the piston is filled with a compressed gas. When the hammer is set in operation, the return valve closes and the ram rises. At the end of the ram stroke, the delivery valve closes and the return valve opens. The ram then falls and receives additional force from the gas pressure above the piston. This results in an acceleration of 2g. A stroke of 1 meter is, therefore, equivalent to a drop height of 2 meters. By changing the gas pressure, the acceleration of the ram can be changed independently of the hydraulic drive. It is therefore possible to generate maximum piling power even when operating at an angle. Energy per blow can be controlled from 5 to 100% of maximum by changing the valve opening and closing times. The number of blows can vary from 30 to 150 per minute. During driving, the ram directly strikes the special anvil sitting on top of the pile. For steel piles, cushioning is not required. The energy control and valve synchronization are initiated by a sensor on the hammer housing. Necessary information is picked up by the sensor and fed to the control panel. The hydro hammer can also extract piles. This simply requires the throwing of a switch. The ram now strikes the limiter beneath the valve ring with short strokes. To maximize the effect of the stroke on the pile, a special cap has been developed. It is simply bolted onto the underside of the hammer. The hydro hammer can operate in combination with standard pile caps. It is often better to position the pile guide on the hammer. For example, as with the driving of sheet piles or freestanding piles. For offshore applications, the pile guides or pile sleeves are primarily used. This enables the hammer to be placed freely on the top without a guide frame. While driving piles underwater, air is supplied through a hose to the hammer housing. The entire driving process thus takes place in air, which reduces drag and saves energy. The air supply is controlled by the electrode set. Because the underside of hammer and sleeve is open, the pressure inside and outside the hammer is equal. This makes it possible to hammer at very large water depths. The electronic controls are just as exceptional as the hammer itself. Controls for starting and stopping, setting the hammer energy, choosing between upstroke and downstroke, and the unit's remote control are all conveniently located on the service panel. Various data are instantly available during the driving process. In the event of a fault situation, a trip number appears on the panel display. An explanation of the trip number is shown on the panel. After correction of the fault and its cause, driving can start again. A special printer, which can be connected to the control panel, is used to produce a report of the driving process. At each 25-centimeter pile mark, a command is given to the printer. It then prints out the depth reached, the number of blows per 25 centimeters, and the average hammer energy over the last 25 centimeters. General data concerning the project and piling are also shown in the report. Finally, a short summary of the piling time and number of blows is given. A more reliable report is hardly possible. Though it's not often required, it is possible to make a more extensive report for offshore projects. In these cases also, information can be automatically given on pressures of the hammer and operating depth. Here, the information is collected on a computer disk for later processing. All parts of the hydro hammer have been developed, produced and tested by IHC to meet the highest standards. In order to service customers quickly, IHC has a large supply of spare parts. The hydro hammer has been constructed mainly from simple modular components that can be replaced fast and conveniently. Every part is thoroughly tested and checked. After assembly comes a functional test in which the piling hammer must operate horizontally. Finally comes a performance trial on the test pile. You now see the hydro hammer in action in the field. First, there are a few adjustments to the terrain. On-shore applications. For cast in situ piles, the pipe with separate bottom plate is driven into the ground. After filling with concrete, the hydro hammer assists in pulling out the pipe or casing. The controllable ram velocity prevents any damage to the concrete piles. The hammer is a cheaper and safer rock breaker than explosives. Because of the controllable additional gas force on the ram, raker piles can be driven with high energy. In ground compaction, a much larger degree of compaction at a greater depth than normal can be achieved. With controllable blows, vibrational resonance in buildings in the vicinity can be prevented. And underwater, before the hammer is submerged, it is subjected to a final test on deck. In this, The hammer operates horizontally. Because of its light weight and remarkable performance, the hydro hammer is often used to drive conductor casings. No energy loss with underwater piling. The hydro hammer has been successfully used at depths down to 450 meters. The hydro hammer meets all the tough demands set by modern foundation technology. For the coming decades, both on land and underwater, the hydro hammer will remain unique and an ultra-high performance unit. From IHC.